Hello, here we go. Chapter 3, Part 2. Starting off basically around page 65. One thing you need to know is ecological efficiency. Ecological efficiency is basically how much energy is transferred from one trophic level to another. How much energy transfers from the producers to the primary consumers. How much of the primary consumer energy transfers to the secondary consumers. The rule is 10%. 10% of the energy in one trophic level passes to the next. That is an average. It actually is anywhere from about 4% up to 40% depending on the organisms. But on average, we consider it about 10% when we look at ecology and our different food webs and our different pyramids. So 100 pounds of hay should make 10 pounds of cow. 10 pounds of cow should make a pound of human. Drop a zero every time you go up 10%. Okay. Trophic pyramids. Here we go. 3 different types of trophic pyramids. We have pyramid of numbers, pyramids of biomass, and pyramid of energy. And we're going to go through each of these. These are kind of important. They will pop up on your AP exam. Okay. So your pyramid, I keep getting the book all crooked. Your pyramid of numbers, here you go. So this is the number of organisms in each of the trophic levels. Producers, primary consumers, secondary consumers, so on. Usually it's going to be a normal pyramid, but it actually can be inverted. You can have a bottom, the producers can actually be smaller than the primary consumers because it does not take size into consideration. So if you go to the rainforest and you have one gigantic tree, there could literally be millions of little tiny bugs that live on that tree. So you can actually see an inverted pyramid. Okay. Pyramid of biomass. So pyramid of numbers can be okay, but it doesn't always give you a real good picture of what's going on. Biomass. Biomass is how much biomass, how much weight is at each level. Again, usually a pyramid, but it actually can be inverted. The reason it can be inverted is because this biomass is measured at a specific time. And if you happen to go to the Arctic or Antarctic, right at the time where the light starts to decrease enough that photosynthesis really isn't occurring anymore because it's getting too dark, you can actually get an inverted pyramid. And that's because these are your plant plankton, your phytoplankton, and they've stopped doing photosynthesis. So, sorry, my dogs are, hey! My dogs are deciding to play in the background. Knock it off, you two. Sorry about that. Stop it! Okay, so bad dogs. So you can get an inverted pyramid, and this is because this phytoplankton has stopped doing photosynthesis, so it's decreasing biomass. There's not as much of it. Right now there's a lot of biomass in your zooplankton and your fish, but these will decrease over time. So later on in the winter, you'll be back to a tiny little pyramid like this. So because it's a snapshot in time, it's one specific moment. If you happen to take it at the right moment, you can actually get an inverted pyramid. The last one is the pyramid of energy, which in some ways is probably the best one. It depends on what you're looking at and what you need. But the pyramid of energy is actually doing your productivity, that primary and secondary productivity, and it's doing it in a given area over a year, usually a length of time, usually about a year. And because it's doing it over a year, it will always be a true pyramid. You cannot have an inverted pyramid of energy. And that's because since you're doing the productivity over a year, it takes into consideration all those variables and stuff like that. And the fact is you cannot have more energy at a higher trophic level if there's not this energy down here. Again, like the 10% rule. Only 10% moves up. If you had less here than here, there's not any energy to support it. It can't happen. So it will always be a true pyramid. It will never be inverted. Okay. Oh, on to the good stuff. Biogeochemical cycles. We're going to actually make 2 videos out of the biogeochemical cycles because I think if I put the nitrogen in with all the others, you'd seriously want to do harm to me. Biogeochemical cycles, we're going to go through the hydrologic cycle. That would be the water cycle. I know you've heard it as the water cycle, but they like to call it the hydrologic cycle in your exam. And I don't want you to get your exam and say, I don't know what that is. Hydro is water. So hydrologic cycle. We're going to go through the carbon cycle, and then we'll actually touch on the phosphorus cycle. and then I'll come back and do the nitrogen as a separate video. So hopefully you're familiar with the hydrologic cycle. The different steps here: precipitation, condensation, evaporation, transpiration, infiltration, percolation, and runoff. You should be familiar with all these. Precipitation, I think you're probably fine with. Rain, sleet, snow, anything liquid coming from the sky. Condensation, actually it can be also solid snow and stuff. Condensation, of course, is water goes from being a water vapor and it condenses to make clouds. So that's condensation. Evaporation, transpiration is when water goes from being a liquid to being a vapor. Evaporation, just out of your glass, out of the ocean, out of the river. Transpiration, of course, is from plants. Evapotranspiration is just these two together. It's one term that covers both of them. Doesn't matter how you do it. Infiltration. Infiltration, if you infiltrate something, it means you go in it. So this is when water goes into the ground. Percolation, if you have a percolating coffee pot, percolation means it works its way through. So water is working its way through the soil and down to our groundwater. And then if it doesn't infiltrate or percolate, that water will run off. It'll hit the surface of the ground and it will run off rather than going into the ground, into the local waterways. Okay, here's a little picture. We're going to have you draw the water cycle in class, but there's your transpiration. That area would be your condensation. This area would be your precipitation. Evaporation. This would be your percolation, water going down to the groundwater. Infiltration, just going in. And then again, your arrow with the water running off, that would be your runoff. Really, I know you guys know the water cycle and probably some of these other cycles. If you don't, you need to learn them. But a lot of what we need to know is that, I'm seriously, knock it off, you two. Sorry, I'm talking to the dogs again. They're driving me crazy. I should probably do this at school. You need to know how we are impacting these cycles. That is probably one of the biggest things and more important things. You need to know the cycle, but you need to know how we're impacting it. So we do a lot of redirecting water. We take water, we put dams in rivers, and we divert water so that we can have it for agriculture or for human use. This is a very big thing in California with aqueducts and stuff. When we redirect water, a lot of times that increases evaporation and will decrease infiltration because the water won't get into areas and won't get into the ground for plants and stuff. So that's a very big deal. We also like to pave a lot of surfaces. We have a lot of roads and a lot of parking lots. That actually increases runoff because that water cannot get or infiltrate into the ground in those areas, so it actually will run off, and a lot of times it carries a lot of debris and pollutants from our roads and our parking lots into our waterways. It also decreases, again, your percolation or infiltration, so increases runoff and decreases your percolation and infiltration. Percolation is really, really, really important because that water actually gets down to our groundwater, which is our drinking water. So we are limiting the amount of drinking water we have in the future. Deforestation also will impact the water cycle. We are having huge issues right now in the rainforest because we've actually eliminated enough trees that it doesn't rain much in the rainforest anymore, which actually causes more trees to die. So if you have deforestation, you're decreasing transpiration, which can actually decrease condensation and precipitation. And we also are increasing your percolation and runoff, and especially a lot of your erosion in some of those areas. If it's at all hilly or on a slope, you'll have a lot of runoff. So this can be an issue too. Okay, so in water cycles or in our cycles, we have what we call stores. So these are flows. This is how the water moves. But we also, a lot of our water is stored. Most of our water, 97% of our water, is stored in the ocean. It spends the vast majority of its entire existence as water in the ocean. Very little of it actually cycles. A lot of it's also in the atmosphere in the form of humidity or vapor. And then we have ice. There's about 2% of our water on our planet is actually frozen in the ice caps and glaciers. So a lot of water is stored as ice as well. Okay. Again, if you have any questions about the hydrologic cycle or any of these cycles, please, please, please don't forget to raise your hand in class and give me a shout out and let me know that I need to go over something or that you didn't understand something. But again, you should be reading every single page in your book, not just watching the videos. So please, please make sure you're reading your book. Carbon cycle, the different steps in the carbon cycle: photosynthesis, respiration, cellular respiration, exchange. That's when the water is, carbon dioxide is moving from our atmosphere and into the ocean and back and forth. Yes, there is air in the ocean. That's how little fishies respire. Sedimentation or burial, when it gets trapped in the ground and becomes rock or becomes fossil fuels. Extraction, this is us removing fossil fuels from the ground. Combustion is burning stuff. The fact is we are carbon-based critters, so if you burn something it releases carbon dioxide. And then fossilization, that is the true process of creating our fossil fuels. Okay, so we are going to draw in class a little diagram and label this, because you have exchange, you have combustion, you have consumption of an animal, you have a lot of respiration by critters, you have fossilization into oil and combustion and extraction. So lots of complicated things in this, but we'll draw a little diagram of the carbon cycle in class. Okay, so again, like I said, one of the big things is human impact. Let me straighten that out. So one of the biggest things we are doing with the carbon cycle is we are burning fossil fuels. Fossil fuels are what we refer to as fossil carbon. It was supposed to be in the ground, never to see the light of day again, but we dug it up and burnt it. So this increases the amount of carbon in our atmosphere, primarily as CO2. And CO2, of course, is a greenhouse gas, so it's actually causing our planet to warm a little. Deforestation also can affect the carbon cycle because you do not have any photosynthesis going on anymore, so it's not absorbing any of the carbon in the atmosphere anymore. But also, if you burn that forest or if you allow those trees to decompose, that is also going to release CO2 into your atmosphere. So it's going to increase the CO2 in your atmosphere in two ways. And of course, an increase in atmospheric carbon in the form of CO2. CO2 is a greenhouse gas, and it is part of the concern with global warming. Okay, as I said with the hydrologic cycle, we have stores. So where is most carbon stored in the carbon cycle? Most of it's biomass. We are carbon-based critters, so a lot of it's in us, in plants, in organisms. A lot of it's also in sediment, in the ground, in the soil and stuff. There's a lot of carbon in there. Fossil fuels are a carbon sink. A sink is an area that literally it's supposed to be sunk there and never to be found again. But of course we decide to dig it up and burn it, not knowing the consequences of our actions at the time we started this. So carbon cycle actually has a sink, which is your fossil fuels. Okay. Any questions about the carbon cycle? See me in class. We're going to skip the nitrogen cycle because it's really complicated and I'm going to do its own movie just about that. Actually, I'll throw phosphorus in with that one. So we'll go ahead and wrap this up for tonight, and we'll do it nitrogen phosphorus cycle in the next video. So have a good evening.